Alright, factoring and solving quadratics part. These are just a couple of other examples that look a little bit different, and there are a couple ways to solve. This is the first one. It says 4x squared equals 36, and I was talking to somebody this morning about how I might do this, and she came up with a totally different strategy than I came up with, and it was wonderful. So here's what she did. She decided to set this up the way that she should. It was very interesting that she picked that out so quickly that she was like, you know what, don't we want this? And she was right, so she added negative 36 to both sides, and when she added negative 36 to both sides, she got 4x squared minus 36 is equal to 0. Remember, we can't add 4x squared to negative 36. These are x squareds, and this is negative 36 ones. So we have to only add like terms. So if you're wondering why I didn't get like negative 32 or something, that's why. So keep that in mind. I'm not making fun, but something to think about here, right? And then what the student said this morning, that she said, well, isn't this DOS? Isn't this difference of squares? And that was really, really smart. And it is perfectly difference of squares. And she got 2x. Right? Here's, because 4 is a perfect square and x squared is a perfect square, so she got 2x here and 2x there, and of course 2x times 2x is 4x, and she saw the negative sign and realized that 36 is a perfect square, so she got plus 6 minus 6 and set it equal to 0. I was real happy with her, and then she started to solve, and she got 2x plus 6 is equal to 0. She added negative 6 to both sides, and she got 2x is equal to negative 6, and x and she divided both sides by that, and she got x is negative 3, didn't she? Is that good math? Sure it is. Then she did the same thing over here, so here's one of her solutions. Brilliant here, so she got her factors here. Here are her factors. And her solutions would look like this, so she got 2x minus 6. This is the technique that you should be using over and over when you're taking these tests. She added 6 to both sides, and she got 2x is equal to 6. She took her time. She divided both sides by 2 and got x equals 3. So there are her two solutions. So factors and solutions. Oftentimes you'll factor to get solutions, but they are not the same thing. So they're different. The other way that this problem could have been done was this, right? We started out with this problem. 4x squared is equal to 36, right? So what I did was this. I just solved this as if this was just x, and I divided both sides by 4. Now, so you get x squared is equal to 9. And you're going to take the square root of both sides. There's a small danger in this because people overlook this. And for as long as I've been around, which is a considerable amount of time, sadly, if I ask you what's the square root of 9, you would say, what number times itself is equal to 9? 3. But that's not the only truth, is it? So x is not only equal to 3, it's equal to positive 3, or it's equal to negative 3, right? What? Negative 3 times negative 3 is equal to 9. Also, it's true that positive 3 times positive 3 is equal to 9. So what's the square root of 9? The square root of 9 is either positive 3 or negative 3. And if you look back at the student's answer from this morning, she had that figured out. So the way I did it might have been quicker, but her way was much more thorough. So again, these are the solutions. These are the solutions. Please keep in mind that this is two numbers. I'll show you here. This is the positive 3 right here, and that's the positive 3. And this is the negative 3 here, and this is the negative 3. So this is actually two numbers. It's positive 3 and it's negative 3. It's just some notation stuff, so it's good for you. Okay, let's try another example. And this one is an interesting example because it looks weird. And it says this. The student is asked to solve x to the third power is equal to 5x squared minus 66x. And it says, when is that equal to 0? Well, first thing that we should look at is this power right here. And this power, the highest exponential power of a variable, gives us some information. In this case, it says that our function might cross the x-axis as many as 3 times. Not saying that it will or it won't, but it might. And we can look at what cubic functions look like. They look kind of like this, or maybe like this if you want it more exaggerated. And so if you wanted to look at that, then you'd say, well, here's the here's the x-axis right here. And in that case, this one crosses once, twice, 3 times. So that's kind of where we're going with all this stuff. So what are we going to do here? Well, first thing I noticed was this. As I looked at the problem, I noticed, look, this term has factors of x. This one has x, and also this one has x. So I looked at that to myself, well, maybe I can factor out an x value, and look what we got. So I factor out, so look, again, looking for the greatest common factor, factor out an x, and then we have to rebuild this, and x times what is x cubed? Well, x squared, isn't that right? So I'm testing this math as I do it, x squared. X times x squared is x cubed. So all I did was change the way it looks. X times what is negative 5x squared? Well, it's 5x. X times negative 5x is negative 5x squared. So far, so good. And x times what is negative 66x? Well, just negative 66. So I'm going to, and if you don't mind, I'll leave my 0 out here. There's no factoring to be done there, obviously. Okay. So there's that piece of math. Now this is where people mess up a little bit because this is a factor right here. So we have to remember to bring this thing down. We're going to keep this. But we have to remember here, really important, keep factoring. We're not done factoring here. Now we can use this little rule here. The value of a is 1. Why? Because it's 1x squared, isn't it? So we need to find numbers. When I multiply these two numbers in my mind, I get negative 66. But when I add the same two numbers, I get negative 5. So we know that one of them is positive and one of them is negative. First thing you know, because this is x squared, that we are going to get x here and x here. How do we know that? Well, x times x, if we redo our FOIL, is x squared. Two numbers that multiply to give us negative 66, but add to give us negative 5 would be negative 11 and positive 6. I'm going with that. That's my final answer there. So these are our factors. I'm going to set it equal to 0. But these are our factors. What are our factors? Our factors are these. Let's move this over a little bit. Right? This is one of our factors right here. This is another one of our factors right here. That's a factor. That whole thing, x minus 11, is a factor. And the other factor that we have is x plus 6 is a factor. So just something to think about. These are factors, not solutions. So we have to ask our question, when does x equal 0? Which sounds kind of weird. Well, x equals 0 when, I don't know, when x equals 0. When does x minus 11 equal 0? Well, that equals 0 when x equals 11, doesn't it? And the last question is, when does x plus 6 equal 0? Well, it equals 0 when x equals negative 6. Try that out for a second. If I take out x and put in 0, well, that is 0. If I take out x and I put in 11, well, 11 minus 11 is 0. And here I said when x is negative 6 plus 6 is 0. These are our solutions. Really, really, really important. Factors compared to solutions. Okay, we factor to get solutions sometimes, but solutions are different. So please be careful, okay? Keep practicing.